Hey everybody, welcome to Houdini Hangout. We are at the end of November, Thanksgiving weekend for those of you in the United States. I was going to say North America, but that's not true because I think only the U.S. celebrates celebrates Thanksgiving. So, Canadian Thanksgiving has already happened. So, yeah. Anyways. Should be a fun week for anybody that is in the United States. And for everybody else, hope you're having a great week and hope your week's been going well. So tonight we're going to be taking a look at the project that we were kind of working on last week and the problem that we got ourselves into. There was a lot of great talk online on the Discord server. So thanks to, I believe, Zach and Kieran were chatting there. Some good conversation and trying to figure out ways to make it work a little bit better. There was some good back and forth conversations there for sure. We went through, or they went through a bunch of options and ideas and things like that, and tried to figure out exactly how to make all of that, work and stuff like that. And after looking at, I think Kieran posted a couple files on there, and after I took a look at it, I was thinking about it a bit more, and I was like, there's got to be a way to do this. Obviously, Kieran showed a way to do that, but I was really kind of still thinking that there was a way that would be even a little bit cleaner. And I know he was kind of talking about like, oh yeah, there's maybe a couple, like there's like a last little stage that he wanted to do or something. I feel like he mentioned on there. But so I got to a place where I was pretty happy with a slightly different technique. And it feels like what I was imagining would happen in my mind. So I feel like it got me where I wanted to. Just had to sit down and really think about it a little bit more. And it's a little strange in some ways, but, I think what we'll do first is kind of talk through this better technique, that or more logical way of doing this. And then we can move on to doing some volumetrics and things like that. So, that's the plan for this evening. So if you're here having a hey, Zach, welcome to the stream. Nice to have you. That's a different Zach than the one that was chatting over in the Discord about this problem. But so if you're joining the stream, you have any thoughts or ideas, things that you want to share or better ways of doing things as we're kind of getting through these processes, feel free to drop it in the chat. Always happy to take a look at that and see, what better way of doing things. Last week, there was a lot of that because I was mentally running into a bunch of roadblocks. Anyways, hopefully this week we won't have that many. It'll be a little bit more smooth sailing, but if you're seeing something that we're doing and you're like, oh, you really should do it this way, please feel free to drop that in the chat. And if you have a question or I haven't explained something well enough, always feel free to ask the question. Probably somebody else is having the same question. So you're doing others a favor as well. So, oh, cool. Well, thank you, Maitland. It was a struggle, and it was hopefully everybody at least got something out of it. We're going to laser slice a ham for Thanksgiving. Nice. What about a turkey, man? Come on. So anyways, that was the, so last week was a bit of a struggle, but hopefully this week we're going to get into a little bit of a better spot. And I'm going to walk through kind of a different way of thinking about doing this and getting it done. You need a turkey model. Just get a little bit of a better way of doing this overall. So, I am just saving my file here. All right, great. Well, why don't we jump over to Houdini and start doing some stuff. All right. Make sure I don't do some dramatic fade here. All right. Cool. All right. So where we left off last time was this model, this setup here. And what we basically had was a bunch of curves, and we were trying to split them. And then what were we doing here? Putting them from P to UV. And we were splitting these by the class that we were transferring here. So it worked. I think I cherry picked a setup that was like clean, and I was just like, fine, this one's clean and works, and we'll figure something out later. And it, like Maitland said, it was fine. I mean, we had a pig with some lasers on it, and we can render this out and take a look at it. There we go. There's our laser pig. So it was working, but certainly was not, I don't think, as clean as it could have been. So what I did was I did a little setup here, and we're going to talk through this a little bit. I think I'm going to turn down the number of laser slices here just to kind of maybe make a little more sense of this. All right, so the way that I went about doing it this time I took the rubber toy. I don't know why I feel like I want to do the rubber toy, but I did. Booleaned it so that it was all unioned and it was all one piece, just because each of these little appendages is its own little piece of geometry. So that cleans that up. Then doing a connectivity by UV. So that gives us a class for each UV island, and I can turn that off, and there you go. We can see our UV islands each have their own class to them. So really what I was doing there, that was just the main like cleanup for this geometry. Then this over here, I could actually put this in a little, put this in a network box, and let's color this dark. Oh, sorry. Color this dark, and we'll just call this cutting geo, because this is going to be the geometry that we're going to use to cut. So we'll just put that there. Okay, so this basically just gives us a bunch of grids here that are copied to points, different random slices using an attribute randomize that you can obviously randomize around. Then getting a Boolean with the AB seams, resampling it here just to make it a little bit higher resolution. It's not actually the most important thing, but it seemed to help a little bit. So just did that. And then converting it to a line. So this convert line is the most important part, because what we run into here, and this is what Kieran was saying, and was great, a great point, was that we have, so if you don't convert it to a line, you can see here that the whole curve is one value, and it's a little hard to see there maybe, but here you can see a 2, a 3, a 0. So pretty much we have 4 curves here more or less, because they cross at this point, and that is going to be where there's a split as well. So here we have one huge curve, right? But the problem is that we can't have like a point discontinuity with a primitive that's only one. Whoa, that was just a big flash. That was interesting. Sorry about that. I don't know what that was. So like I was saying, we can't have the ability to kind of pull these points apart when we have just one big curve like this. So we need to actually split this apart and have these as individual primitives so that we can split apart between these. So obviously we could have gone through it and like figured out where it needs to cut and all that stuff, but the convert line actually changes it so that we have all of these points here that have point numbers, and then in between is a primitive, right? And so this is a way for us to be able to, hey, Fractaler, welcome. Oh, hey, Zach, welcome. So I go by Zach is actually the one that was having the conversation, and Zach Karada is a different Zach. But anyways, how you guys doing? Welcome. So, so we have these different primitives, right, with points in between them. And what we need to do at the spot where we're actually crossing this this kind of attribute threshold, we need to have some sort of a cut there, or do something in that nature. Now, we could actually have this cut happen, but an interesting kind of Oh, right. Sorry. Actually, an interesting part of this line, now that I'm thinking of it, is that the point is actually on this line. We can do the laser cut directly on Karma without additional curves. Oh, cool. I'm not sure how to do that, but that's cool. I am not familiar with that. Hey, Jebin? I guess Jebin. Yeah, this is the usual time of the streams. You've been watching my last few recordings. Yeah, this is normally when I stream. This is right after work for me, so it's kind of the earliest that I can reasonably stream most days. So, okay, so I'm just thinking about this, and so the interesting thing here, actually, as I'm talking, is that we have this geometry, right? And it's when we're doing this Boolean, we're actually getting. Let me see here. Can I show this easily here? No, I'll show this. Okay, so that, right? When we have that, and then we have these lines like this, the points on those lines actually correspond to crossings on these primitives, right? So each one, so this point right here is going to exist as a, as a place where we want to split this. And if we resample it, yeah, that actually moves. Okay, interesting. So I actually don't want to resample it until I split it. Okay, interesting. Anyways, sorry, just thinking about other things as we're talking through this. But so what we need to do then is we need to take these points, right, that are at these these island crossings, and split them apart, right? Because those are going to be in different regions of space. And so we need to be able to do that. So what I realized I needed to do was a couple things. One was to convert this over to a line so that we have each of these as individual, line segments here. And then attribute transfer the island, the UV island and the UV attribute over here. So now if we look at these, we can see that UV island attribute, and I could probably darken this up just so you can see a little better. You can see that these UV island attributes are now copied over here, and we can see the different colors and things like that. So from that, we can then go through and do the split UV seams here. And what this is going to allow us to do is we can split at those individual points, right? And so the thing that's interesting about this is that we are going to have these broken now, right? So we had, actually, sorry, I'm just realizing I can, oh, bummer. Sorry, give me 1 second. There's something, I actually have a little drawing utility now that I could possibly work with, but, oh, I turned it off. That's why. There we go. Okay, so I have a little, that's cool. Okay, so let's see where we're at here. We have these individual points, and we want to split them at the UV. There we go. Okay, so we're just going to resample it. We're going to let it split. I'm not sure why the resample was necessary at the moment, but seems to be necessary. Oh no, it's doing it there. Okay, sorry. Anyways, so where are they? There they are. So here we can see that there's actually 2 points here now, right? So this point right here is now splitting between a point that's kind of on this primitive and one that's over here, right? So we have these 2 split points. And so what I ended up doing then was taking in the geometry here that's got all of these, it's separate UV islands and stuff like that. And I'm going to go through a for each of the curves and blast it out that way, and then transfer over the UV. But what I'm doing there is actually getting just basically, so I'm taking this piece, right? And so normally we have pieces that are right next to each other, right? And so in those cases, when we have that, right, we have these two separate pieces here. Sorry, I'm trying to think of a good way to show this, like this. So when we have these two pieces and these curves here, right, and there's a point that sits right on top of them, what it's doing is it's, we have to have basically this point right here is sampling either on this side of the UV island or on this side of the UV island. And so that point is naturally going to get pulled one way or another. So what we do once we split it into two, so now we have 2 points, right? We have a point here and a point here. Now they're technically right over top of each other, but when we separate them by their UV island and basically have them that way, we now want to take the closest on this side here to this point, and then the closest on the other side here, we want it to go to this point here. So, so basically that's what we're doing, is we're pulling this point like a minuscule amount to this side, and the orange one here, we're pulling a minuscule amount to the other side. So that's basically what we're doing in this for each loop. So here you can see we're pulling this geometry in, we're transferring that attribute over. And so we're basically just getting this to be on this UV island here. And then when we for each this, now they each have different UV attributes. So if we look at those, like, let's see, where's a good spot where we could see this? Like right there. There's a good spot. So let's select those 2 points right there. So let's do select 2. We'll select those 2 points and we'll say show only selected. So this is 392 and 263. So there's the UVs for each of those points. And then when if we looked at it up here though, and selected these both, we can see that these have the exact same, or basically the exact same UVs. And when we come down here, those two have now drastically kind of departed. So now when we split these apart, they're actually going to go to their own respective UV islands. So here, if we look at this and change over to here, you can just, oops. I actually used it this way. You can actually just promote the UV to the position that way. And if we look at it here, we can see, I'm going to turn off the UV islands and make this a little smaller here. There you go. We can see that we have all of those pretty much properly connected. And we could add quite a few more of these. And we should be able to have tons and tons of them and not have them cause any issues. The other possibility too is that what I was thinking about here was, yeah, it's working. So I'm happy about that. I mean, obviously, Zach and Kieran's conversation was super helpful for me to like kind of clear my mind and think about it better. So, I mean, huge props to them. They obviously had some thoughts about this as well. So the one thing that is a little off on this is the UV island transfer. Because we're using the primitives, there is a bit of a weirdness there. And I think what would actually be better is to figure out, like basically calculate the distance from each point to the corresponding UV island, and then promote the closest UV island to the primitive between the 2 points. It's just a lot more work, so I didn't do it that way, but this is pretty darn close. That would probably be the cleaner way of doing that. Same thing maybe here. It might be better to use a some vex, but this is simple enough. So anyways, we've got these sliced. It's working. I put them into the same Copernicus network. They're doing exactly the same thing we did before. Nothing crazy there. And then, yeah. And then from there, let me just take this laser curves 3D. So we don't have to actually worry too much about this, these points. What we could, of course, do, I'm going to undo that. We could always resample these if we wanted to. I think we could resample them here. And this would be fine to do. It's funny, the dark with the light blue is not the easiest thing in the world to see. So hey Zach, I was just giving you the benefit of the doubt. So Fractaler, the question is, to be sure, the difference between last time is the for each loop. Yeah, so from the last time I was doing a for each, yeah, I really wasn't doing a for each loop with it. And I think splitting it up this way, where I'm pulling in obviously all the geometry, then blasting out, the points based on, or the piece based on the whatever current, because I'm going over the UV island piece attribute, and so that's getting fed into each of these here with a detail attribute there. And no, this is just blasting it out, but I'm using this metadata block to pass it over here. So that is what I'm pulling in. You can see here I'm pulling in the value. So the value of the UV island is getting passed into this blast node each time. So it's blasting out the corresponding UV island to the UV island attribute that's on the curves. So it's just doing that basically. So yeah, so that's the real difference. And really what's happening there is it's constraining it in three-dimensional space so that the curve and the UV island from the original geometry, so that you basically so that you can have it go to the edge of that UV island and pull the UV attribute from there instead of pulling it from wherever the exact point is, because the point has to choose between one of those two UV islands. It can't split itself, right? Like, because it's in one physical spot, so it can't choose on either side. So this is basically isolating it, so it has to choose the UV island that's on the side of it, right? So it's just basically isolating the three-dimensional space so that it can't flip across that UV boundary. Okay, anyways, so here are these lines. Just curious if this changes anything here. Probably not really anything, but yeah, really nothing. So we're just going to delete that because there's no reason. Quantum level troubleshooting. No, it just was sitting down and thinking about it and just getting somewhere with it. Okay, so all right, let's now go over to, I put a Solaris network here, a LOP network up here. Here's our geometry, our rubber toy. One really strange thing about this, and I don't really know why this is the case, but this make instanceable is checked on by default with the rubber toy. Is that true with the pig, actually? It is. So with that, I couldn't apply the material properly, and it wouldn't pick up the material if this was make instanceable, because I can't, within your geometry spreadsheet, you can't go lower than this level of the rubber toy. And I'm pretty sure the material is, yeah, there's a material applied there. So applying a material higher up the chain isn't actually like doing this. Where is it here? Rubber toy there. This isn't actually going to do anything. It's going to put a material binding there, but the actual one that counts is the one that's lowest, like on the leaf node, basically at the most child node, basically, or the most child primitive is it takes over. So anyways, I had to uncheck the make instanceable. So these are all writable so that I could then take the shape and drop that over here. And now the lasers come through. And if we go in here and do CPU, we've got some lasers. So hooray, we're doing stuff. Things are happening. We've got our lasers back, happy, everybody's good. Okay, so the next thing that I wanted to screw around with was some sort of a volumetric representation of this. So I think what we're going to do is let's start messing around with that now. So I'm just going to do this as the 3D laser lines. Cool. All right. So let's do geo, and let's call this geo. Let's call it that. And let's start screwing around with this. Okay, so let's pull in our, well, let's make a null here so we can pull that in, pull a couple things in here. So we want to bring in our geometry because we're going to probably, we'll take that out of the volume so the volume isn't maybe going through it. That would be kind of strange, I think. So let's do that. All right, so let's do a null here, and we'll just call this we'll say in geo, and then here are our cutters. So I'm just going to say null, drop this over here and add a cutters. Make those both yellow. Cool. So this is going to be our cutting geometry. And that should work well for us. Cool. I don't think we're going to need those as separate geometries. I don't think so. I think all just as one like that should be fine. Okay, so let's bring those in. Let's do a couple object merges. To get cutters. How big are those? Yeah, maybe I should make those just a little bit bigger. Just want to make sure we've got a nice amount of volume here. So let's do 15 by 15. So I'm just making these a little bit bigger just to have our, lasers, coming in a little bit wider. So they're coming in from further. All right, so let's do that. Why don't we do a bounds on this? And that can give us our volumetric boundary here. Let's see, like that. Yep. Cool. There's our object. Yeah, hopefully that's not too small. We can always, or too big. We can always make it smaller with this bound node, so that's fine. All right, so let's do a VDB. We'll call this just trying to think what we want to do here. Maybe we'll call this emit, because the density is just going to be the whole thing. And then we can also do density. Background value can just be 1. That, I think. And okay, so then I think we do VDB activate. Okay, there we go. That's what we want to do, actually. All right, that seems a little bit too much. Okay. We'll start with 0.2, see where that gets us. All right, so we have our bound geometry, or our bound area there. This is our geometry. I think we want to pull this area out of this this activated region, or set those values to 0. I think. I guess it probably doesn't really matter. Well, we'll see. Maybe we'll do that in a little bit. All right, so we have our bounds for our cutters. These are our cutters themselves here. And what we want to do is activate those. Oh, actually, you know what? Can I set these? Does that work? Yeah, okay. So we'll set the density. So I think what we want to do is have the density be there's maybe a couple different ways we could do this. We could have a existing like noisy density and have the lasers go through it like it's going through a cloud or something. That's possible. But I think maybe for right now we'll just have it be like a uniform fog. Maybe that's what we'll do. So let's actually just do this. Let's do the emit like that. And let's just do another activate here, and we'll activate the value to 1, and we'll activate density. So this way, now we have our emission. Our emission should be set to 0 here. This is activated. Now we have our density. Density's at 1. All right, cool. So that looks like that's working. Let's do a volume wrangle here. So let's pull this in as the second input. And maybe actually a even better thing to do would be, let's just do it on the emit right now. And then what we could do is we can at least see kind of what's going on here visually, like how it's pulling these values in. So if we did, I think what it would be is f at emit equals 1. That should all be 1 now. Okay, cool. I'm just making sure that the syntax is what I'm expecting here. I don't do volume wrangles all that often, but I think what we're going to really benefit from is the ability to do XYZ dist. And this is going to be the geometry, the closest point to the surface, right, of a geometry. So what I want to do is say, that's probably a little hard to read. Let's just do, can I do this? Oh, sorry. I don't know why that wasn't working. Okay, anyways. Let's just pull up XYZ dist so we can see it. not XZY. Oh, there it is. Okay. So let's see here. This is probably a little visually easier to read. So the one that we want to use is, we could just use the basic one, right? Because we don't really need to get the primitive or the UV. That's not really, doesn't really matter. What we want to know is the distance to that actual, to the surface, right? So we just want that distance value, and we can then clamp that so that our laser will basically only be a certain distance from that surface, right? So let's do this. Let's say float dist equals XYZ dist. The geometry we're going to be looking for is 1. We want the second input, and then the origin should just be V at P. So this should be the current position of the voxel that we're sampling. So that should work. Cool. And then if we did, let's see here. Let's do, well, let's just see what that looks like. Emit equals dist. Let's just see that one, see what that does. So we should see that, yep, there's some lines in here that are basically corresponding to those cutting geometries. So that's working at least. So that's good to know that we're getting the right value there. However, when the distance is 0, the density is 0. So the value is going to be basically 0 where the surface is. And so we want to invert that. We want to have some sort of a we could do it with a ramp, probably would be fine. Yeah, a ramp's probably a good idea to use. Let's first fit it though. So let's do, let's say dist equals, then we'll do fit. I don't want to do A1 because that's not really going to do it. So let's do dist, and then we'll say 0 to, and we can kind of control what the next closest value is going to be, right? So we could say, how far do we want it to go? Maybe we'll say, I don't know, 0.5. And then 0 is going to map. So the distance of 0 is going to map to a certain intensity. So let's actually go a little further with that. Let's make it 2, for example, just to make it, maybe that's like a brighter emission. And then when we go to 0.05, it'll fall off to 0. So that should fit it. Yep. And there we go. So now we've got this kind of area that's being fit like that. Let's just do this a little nicer here too, just to make it a little bit better. Let's say float max dist equals, and then we'll just do CH and say max distance to cutter, like that. And let's make a thing from that. And then we can say 0.1 for that right now. And then we can swap this one over to max dist. And now we've got a nice little procedural, not procedural, but a nice, yeah, I guess procedural little way to kind of have these things work this way. Now there is a way to do this better and have it super sampled, I think it's called. And that actually would be a better way of doing this, but I'm not going to be setting up any super sampling right now, I don't think. So we'll just use it as it is. Basically super sampling is like taking multiple samples within the area that the voxel would be and getting the average amount of the distance to the surface. And so that would give you better like anti-aliasing of these and not such a harsh line, but I think we'll be okay. I don't know. We'll see. We'll see what it looks like. Hopefully it'll work fine. Worst case scenario, we have to make the voxel smaller. Yeah, actually kind of fine. We could do that, I guess. Anyway, we'll have to see how that exactly works. But there are the... It's a little strange that there's like these dark lines here. I'm not sure why that is. There's probably a good reason for that. I'd have to think about that. But anyways, there is the emission, and then we could come down here and activate the density from that. So then we should have our density and our emission. And I'm just trying to think if there's anything else we need here. No, I don't think so. Let's just see what happens here. Let's do a null, and we'll say okay. There's our laser volumes. Cool. Let's go over to Solaris, and we'll import those as well. Here, let's just do a SOP import and merge them in. Let's grab that location. Laser volumes. Cool. So these should be coming in as VDBs, which they are. There we go. All right, let's clean this up a little bit because this is a little silly the way that we're doing this here. So let's do /world/geometry $OS. Okay. And then the rubber toy can actually go in the same spot. Here, we can give it the same thing there. Great. This I'm going to say is going to go into, yep, we can do the same thing for that and say laser volume. Rubber toy, great. And then here we go. We've got some materials. Let's change this to be /world/materials like that. Same thing here. And then I'm just going to reassign those materials because unfortunately they do not come over like that. So that's okay though. So this, and then we need our laser material. Then our ground material is going to go down there. And our grid 1 we can slot in there. And I'm actually just going to hide these for a second just to make sure that we're in a good spot. So here I'm going to change this to be /world/camera. And that's great. That needs to go in that spot. And we'll just change our camera over so that it's picking up the right camera. And put it in a good spot there. It looks like it's working. Great. Okay. So if we turn this on, let's just see what happens here. See if we get anything going here. Okay, so I'm going to need to make some sort of a volume here. I should be able to hide these, right? If I do that. No. Okay, if I do that. Okay, great. So let's just turn off the emission for now. And let's do our, let's see here. Let's do material library. Drop that in there. And we can use this to do a karma. Volume limit is by default 0. I don't know what that means. What do you mean by volume limit, Fractaler? It's 0. Volume limit. Oh, you mean that the rays can go through it? Yes. It is. That could be what's happening there, I guess. Probably is, actually. let's do this. For now. I could just say... Actually, isn't there a... There's a karma fog box, but I don't think... Maybe there would be a way to do that. Anyways, I'm not going to worry about that this moment. The fog box thing. I've never actually used that before. But yeah, that's true. There is the limit of volume is set to 1. So, I mean, if we go crazy with this, I don't know if we're going to see anything. Yeah, not really. I mean, we should definitely set it to 1 at least. But, okay. So, let's say laser. Let's call this laser fog. No, yeah, good call. That definitely is right. I always forget about that. Okay, so we should have a material here, but we're going to change this over to be that, and that's going to put it in the actual materials there. So now that should be next to our other materials. And if we use an assigned material, can we actually drag this over like this? We probably can. Let's do volume 0. Interesting. Just going to back up here just to see what's happening exactly here. Excuse me? What on earth is this pattern? UV unwrap fog. Yeah, what is that? Oh, right. I'm in the camera. Dang it. I'm just going to use this sign material because it added another one for some unforeseen reason. So we'll just do that and do this. Unlock that. Oh. That's a great point, Mr. Gozo. Why is it? Oh, thank you. Thank you, thank you, thank you. Why is that? Oh, this is why I did a dumb thing. There we go. There's laser fog. Thank you very much. That's exactly the problem. I have the wrong material applied to it. I was looking for laser fog, and I saw laser material, and that was very strange. Okay. That explains. Thank you very much, Mr. Gozo, with coming in clutch. Thank you very much. And now we should actually have maybe some fog here or something, maybe? And now we have no fog, which is very, very confusing to me. Okay. Why is my density... Am I using Karma Fogbox? No, I am not, but I can give it a shot. Okay. The only thing that I'm not sure about here is... how I would go about... getting those lasers in there, because that is working. For the density, well, maybe what I would do then is have... Okay, so I could do this for like the background fog type stuff. The only thing I would have to do here... Oh yeah, Kieran, that's what I was doing, having the lasers affect the volume, because I have all the cutters going through it and stuff like that. Not the ones on the surface. Okay, let me put this in the right spot here. And we'll just call this laser fox. Okay. There's that. Cool. We'll call it laser fog box, just to keep things straight a little bit. I think since they aren't light geometries and only texture, it will not affect it as much. Yeah, that's why I was doing the volume thing, because I want that to emit in there and have that be the actual lasers and stuff like that. So I think actually what we could do is change this a little bit. I think the better way of doing this would be sorry, this one here. I actually think if we put this down here, could probably have this work with both of them. And then we should have both the density and the emission on top of each other. They should be this roughly the same value. I guess I could. I guess I just need density there. That's all I really need. I don't need the emit. I don't think. I think we could get away with just the density. That we don't need. That activates the density. That sets the density. Why is it not grabbing the density there? Sorry. What did I do? I did something stupid there. Oh, I see. It's just written in my code. That's why. So this would be density. Thanks, Zach. I should have looked down there sooner. You definitely called that out for me. Sorry for not noticing. Okay, there we go. Laser volumes. Cool. Let's go over to Solaris. We could bring in these laser volumes here. And then oh, sorry, here. This is what I want. So let's do this. Just trying to think of how to pull in the density. Can't remember the node that I would pull in to wire the emission into that. Let's see here. Okay, maybe I could do this. Intensity comes from the density. I could just wire that in there. Maybe. Honestly, sorry. Duh. There's no reason to do that. I could just do this over here and turn the fire on. And then I can do density and density. Kieran was saying, so I have a suggestion. Go inside the Karma uniform volume and copy paste the volume atomic node. I'm not sure what you're saying there. Pyro shader, yep. This? And copy and paste that, you think? All right, try it. So it's just a Karma volume? I mean, I could just use a Karma volume, right? Yeah, it is the... Yeah, it is the material for that one. Yeah, so I pulled the same thing out of there. Yeah, I'm just not sure. Like within here, if we go to the emission, right? The emission is... Just don't understand where... mask, maybe? Huh. I guess all I need to do is do maybe a parameter like this. No, no, because that's not going to get. All right, I'll take a look at what you sent me. Not so uniform volume. I like that Kieran named it not so uniform volume. That's good. All right, let me see what on earth is going on here. Yeah, are those responding to the lights though, I think, right? Yeah, I want it to actually be an emissive material is what I'm trying to, or an emissive volume, which is what I'm trying to do. For some reason, I can't get it to work. Oh no, that's different. That's the volume mask. I'm not thinking straight. Hmm. Yeah, it's possible, yep, to get a volume to act as geometry act as a light, but no idea for volumes. Yeah, it should be able to be done with the emissive nature of them. What? Hello? Match current definition. Let's just throw this back in here for a second. Okay. All right. That's working a little bit better than it was before. Okay. Let's play around with this a little bit here. All right, that's starting to do something interesting. Another thing I forgot about was that these lasers are coming from the bottom as well, so we don't want that. It feels like they're scattering too much. Let's see. I'm going to throw this down here. And I should be able to edit those values. Okay, before I go editing this, let me just play around with this a little bit here. I need the background. A volume slit scan. No, I'm just looking to get the lasers coming through some smoke. Let's see. Background is too bright. I mean, the problem here is that the lasers are not... This isn't the way lasers work. They don't go all the way around something, which is a little bit funny. Yeah, that's interesting. You'd have to... Quantum lasers. Yeah, quantum lasers would. Sure. That's great. That's a great point. You're very right. And yeah, there'd be lasers on the ground. Why is my background like white? I'm just going to turn these off for a second here. Lasers are just sharp pinpoint light. No, so just lines. Yep. Yes, exactly. So lines, yes. But they'd be going through three-dimensional space like a plane, like if you had it like a laser level type of a thing, when you have like a 360 laser level, and if you had smoke in the air, it would be like a ribbon of light that would go in all directions, like a flat grid. But yes, a laser is just a point. Yeah, for sure. Slit scan. Yeah, I guess. Sure. Yeah, I'm not sure what slit scan is, but that's sure. We'll say yes. So, yeah. What was I going to do? Oh, I can just set the background here. That's better. Make it in SOPs, bring it in. Like this? I Let's just do a couple of them and see how it looks. See if it looks any better. Oh, let's see here. Make this a little bit bigger. Yeah, so this... Yeah, that's what I'm thinking of too, is like the fog with the noise. We had this laser fog, the fog box does have noise involved with it. But I think it would probably be a good idea to turn this into a geometry light, actually. Forgot about that. Sorry, mesh light. Yeah, that's working a little better. Yeah, kind of. Yeah, that's kind of what it is. It just would be a straight, just an individual straight line instead of like a cone. But yes, more or less. Kieran, yeah, he put a video there in the Discord. If you didn't see that here. Yeah, I think it's possibly too thick. I'm gonna let that go for a second. I've made a mistake. Turn this volume off for a second here. Let me turn this back to something where I can see it. I'm not sure why this fog box seems like it's... Oh, okay. There's the noise in it. Yeah, maybe we need it even bigger. Yeah, I think you'd need the... Yeah, I think you're right, Zach. You need the noise to be in the VDB of the laser lines. Yeah, I think you're right. I think you're right. I'm just trying to think if there's anything... Yeah, I agree. Fractaler and Zach. Yes, I think those are good points. Okay, maybe I leave this as like a... I don't know. What does this look like without that? Just out of curiosity. Let's see here. The fog box, yeah, would help as global fog. Yeah. Should I dare to switch over to XPU? I'm going to try it. It's safe too, just in case my whole computer loses its mind. All right, let's do that. Just disable the smoke, actually. Don't need smoke, we just need the fire. Yeah, and we almost want like the lasers on the ground too. That would be cool. Okay, let's go back to these geometric lasers. The one thing I wasn't even thinking about here was that there's literally no point to have anything below there. So let's just do a clip here. And if I clip it like that, fill the polygons. That's just way better. It's going to be way more efficient. And then maybe I could go down a little smaller. Okay, so yeah, I really need to super sample that, and then it won't be so weird and aliased. But again, wouldn't adding the ground with Flippy before the Boolean help for the laser on the ground? Yeah, so the real way that you'd probably want to do this, as I'm thinking about it more and more, is that you'd want to have a point that would basically, like, kind of like what Kieran showed on Discord, if you saw that. It would basically be like a flat, almost like pie shape thing that would come out, and where that intersected your geometry, you know, you do your Boolean from that maybe. And then you could only keep the lasers on the side that's closest to that point, basically, where the normals are positive towards that one point, if that makes any sense. And then from there, you could also project that same thing on the ground, but I think, like, it's just rasterized lines. What's just rasterized lines, Kieran? You just use light projections. Yeah, you could. I guess you could use like a gobo on a light, I guess. Yeah, I guess that would be pretty easy to do, huh? It's fresh. Thanks, Zach. Well, maybe I just did something way overcomplicated. Who knows? But it's something. Yeah, so let's add some noise into this volume here, right there. Let's see. Let's do a volume VOP, just because that's a little easier to do the noise with. And I like the quantum laser. Yeah, it's kind of interesting. All right, let's do noise. Cloud noise? Let's see. Multiply it maybe. Yeah, there we go. No, I actually think it looked a little better with it around 1. Let's keep that at 1 as well. I don't want to be pushing the values too high here. Cool. I mean, you could animate it, do all sorts of things to it. Let's try that. See what that does. Oh yeah, there we go. I'm seeing the noise. I mean, that's too much. Yeah, obviously you'd want the lasers on the ground and stuff like that for the effect. Yeah, so I think what you really need to do is get, like I said, you can sample the noise a little differently and get a better look out of it. But yeah, I mean, it's something. I'm not sure if it's exactly what I wanted, but we're getting somewhere with it. I am now really curious to try the gobo projection thing. I'm not sure how that'll work or not, but let's just do some stuff here. Sorry, don't need that. Let's grab the rubber toy. Don't need the laser volumes. All right, sorry, I saw a little flashing there. This, I'm just going to grab a separate fog box. All right, let's start to mess with this a little bit here. All right, fog box, check. And let's put a light up here. Let's do a spotlight. Oh, cool. Kieran, you should be doing the stream. All right, everybody, you can go check out Kieran's stream. It's over on Discord, Houdini Hangout Discord. Let's see here. Cool. Yeah, I'll have to. Let's see here. I am curious what you did there. Let's take a look. No, I'm not going to change it to a dark background. So you're just right. So you're just rasterizing this into a volume here, and then putting a ramp on it, basically. Right. So that was sort of what I was doing, I guess, a little differently. I wasn't rasterizing it that way, but yeah, I would need. But no, it's super cool. I like that a lot. Yeah, everybody should go. Everybody should check that out on Discord. It's a nice little file there to take a look at as well. All right, I'm going to minimize that, and then I want to try this here and see, just out of pure curiosity, if I can get any like lasers in that, because that is an interesting idea as well. Oh, maybe the connection dropped for a second. Sorry about that. It could have, if my computer was doing a bunch of things. Sorry, it could be that my computer's mad right now because I'm doing too many things simultaneously. So let me just close that out, and hopefully that maybe will be a little nicer. Sorry about that. I could have dropped the connection. No, I didn't drop any frames, but definitely my computer freaked out for a second, I think. I think I'm back now. Sorry about that, everybody. It looks like I'm running into some issues with my streaming provider. So certainly something on my end here. Sorry about that. Yes, back. Huh. That's weird. I haven't had that issue in a very long time. Yeah, it looks like I'm disconnecting from my streaming provider. So anyways, what in the world is going on here? Why is this seems insane. Why is a light not working? That's so bizarre. Of course, it's a viewport thing. So annoying. Anyways, sorry. Okay, let's try to do this real quick. Let's put a spotlight in here. See you, Kieran. Thanks for the suggestions. Those were awesome. Those are very cool. Thank you. I should have Kieran on one of these streams one of these times. That would be very cool. Very smart guy. Okay. Spotlight. Okay, cool. I was like, I feel like I'm losing my mind here. It like wasn't working and I was so confused. Okay, let's change the background again to dark. Oh, this fog box is annoying because it like stops me from being able to tumble around in the scene well. Because it's got like bounds and stuff. Oh, it's really annoying. Anyways, okay, let's do that. Light shader. Is there a gobo in here? No. Light filter library. Okay, let's try a gobo. And I wonder if I could make something in... let's do a Copernicus cop network. Let's just see if I could do a... I don't know, is there like a grid? No. Is there a way to do the checkerboard but without... No. Oh, I know. I could just... Let's just make a SOP network here, and I will import from it. Or actually, no, sorry. I can actually just do that right in here. SOP geometry. So I can go inside of here, do a grid. We'll just do convert to... convert line. I think that should work. Yep. Okay, so let's just make this less. I don't know, 4 by 4, something like that. So, and let's UV project on here. So we're in UV space. We'll just, sure, fit to best plane. Looks good. Okay. So there's our lines. Tile pattern, cool. That's great. Didn't know that was a thing. Thank you, Zach. I knew there had to be an answer to this. Thank you. Thank you, thank you. Let's see here. Divisions. There we go. Cool. Shows how much I use. Shows how much I use Copernicus. Okay, let's do that. Let's see here. Spot. Or no, in here, I think. Yep. Okay, so let's do op colon. Can I do this? No. Oh, weird. Okay, I guess I can't do that. Let's see, obj, or, sorry, slash. No, okay. Solaris, and then cop, net, outlines. Let's see if that'll work. And then I think if I do this and light filters. Light filter library. Yeah. Maybe I can't do it that way. Let me just try a. Let me just try something different here. Can you use the CopNet outlines directly in the light shader? No, I think it needs to be one of these gobo things here to be able to do it. I think. Well, I've never used those before, so that is interesting. I've never even tried that. Get one or more available light filters. Oh. I think it's this way, actually. Assign to light. It's the other direction. Interesting. Okay. Well, that's working. All right. So instead of that, let's Let's do the same thing I did before. Op colon slash obj slash Solaris slash copnet1 slash outlines. Okay. All right, so that's working. Let's see here. So if I go into here, we make those yeah, that sort of works too. It's kind of like, yeah. Sort of the same thing, I guess. And if we did the noise on this, yeah, you could kind of do something like that. Ugh, moving around in this scene is really a pain in the butt with that. Yeah, so, well, there you go. There's another option for like lasers and things like that, I guess. If you wanted to project it through some fog. All right. Well, that's probably the last time I'm ever doing lasers again. So have fun doing them yourself next time. Oh, man. Crazy, crazy, crazy. All right. Well, we got something. And, you know, isn't it really just the journey about getting there? All right. Well, thank you all for joining tonight. I am pretty sure that I'm going to be taking off for December to kind of regroup myself mentally and come up with maybe some new ideas and some new techniques and things like that for some of these things that I've been like wanting to do for a while, but just haven't put any time in. So I think that's what I'm going to be doing. I will certainly be announcing it officially on the Discord server whenever I make that choice. But yeah, I think that's probably what I'm going to do. But for now, we'll just say totally about the lasers. Well, yeah, hopefully you all learned a valuable lesson that lasers aren't as easy as you thought. And yeah, there we go. And yeah, I've got hopefully some cool thoughts for other, some other streams and stuff like that I'd like to tackle. So maybe putting a little bit more time into things and working on the stream and working on a bunch of other things, just getting things better buttoned up, hopefully, for the new year. But yeah, I guess, like I said, that's where we'll end it for today. And hope to see you all soon. Keep an eye on Discord for any announcements or anything like that. And I will talk to you all soon. All right. Everybody have a great night. Happy Thanksgiving to those that are in the U.S. and have a great rest of your week to anyone else. So, yeah, have a good one, everybody. See ya.